Hello and welcome to this video tutorial. In this video, you are going to learn about Mojo versus Python for machine learning. Mojo and Python serve different purposes in the context of machine learning. Python is widely used as a programming language for machine learning due to its rich ecosystem of libraries and frameworks, while Mojo is a hardware description language that's used for FPGA, which is comparing Mojo and Python for machine learning. It's not straightforward because they are used for different aspects of the machine learning process. Python supports large ecosystems. Python has a vast ecosystem of machine learning libraries and frameworks, including TensorFlow, PyTorch, scikit-learn, Keras, and more libraries. These libraries provide extensive tools for data pre-processing, modeling, and evaluation. Python is easy to use. Python is known for its simplicity and readability that make it accessible to a wide range of developers, including those new to machine learning. Python supports large community and it has a huge resources on the internet. Python has a large and active community of machine learning practitioners, which means you can find extensive documentations, tutorials, and support. Python is also flexible to use. Python's general purpose nature allows you to integrate machine learning into a broader range of applications and systems. So these are the basic features of Python programming, and let's try to see about Mojo for machine learning. As I've said, Python and Mojo are in different aspects. So Mojo is not typically used for machine learning model development, but we can use Python for developing uh, machine learning models, but rather for deploying machine learning models on FPGA hardwares. Here's how it relates to machine learning. For example, FPGA acceleration. This is hardware-based acceleration. It is basically used for deploying machine learning models, not developing machine learning models. So you can develop machine learning models using Python, and you can deploy using FPGA accelerator. Mojo can be used to program FPGA devices to accelerate machine learning references. This is often done for real-time and high-performance applications where GPUs or CPUs may not provide sufficient speeds in Python. So FPGA means that is a field programmable gate array. So it is basically used for deploying machine learning models. It has a custom hardware. So FPGA devices can be customized to perform specific machine learning operations effectively, which is especially beneficial for edge computing and IoT applications. That Mojo also specialized use cases. Mojo is more relevant for engineers and developers working on hardware accelerations for machine learning rather than data scientists or machine learning model developers. So this is basically for uh, engineers and developers who are working on hardware accelerations for machine learning. It is basically for deploying machine learning models because of uh, speed, CPU and GPU speeds. In conclusion, Python is the primary language of choice for machine learning model development due to its rich ecosystem, ease of use. On the other hand, Mojo is used for hardware acceleration and is most relevant when you need to deploy machine learning models on FPGA hardware for specialized applications. Typically, they are used together with Python to develop the machine learning model and Mojo to deploy the model on custom hardware for optimized performance. So you can use Mojo and Python together to deploy your machine learning models on the customized hardware for optimizing performance. And welcome back to this tutorial. In this tutorial, I will show you how to install Mojo Software Development Kit on your computer and how to configure Mojo on Visual Studio Code to write Mojo program. Okay, go to the developer.modular.com and click on download, and you may need to sign up or register to your Gmail account, and you can automatically continue through your Gmail account. And once you sign up, you can look at this commands. By default, so Mojo is developed for different platforms. You can look at and the drop down of this option. So if your PC or computer is Mac, you can choose Mac. If you are using Linux, you can choose Linux. And if you are using Windows, you can select Windows setup, how to install Mojo. Then I'm personally using Linux, and I choose install on Linux drop-down menu. Then I can, if you are using Linux, you can copy this command, bash command, and go to the command line terminal, and you can paste here. And it will install update your system, then install the modular. Once the modular is installed, it's going to clean up and install the Mojo SDK. Then everything that's required to configure Mojo will be installed on your Linux machine. The same is true for Windows and Macs because I'm using Linux. Then once successfully completed installing the Mojo, you can look at the end of now. Mojo is installed successfully here. Mojo is a Python virtual environment, so it is created this is the path or the location where the virtual environment is created. And then you need to export some, if you are using Bash, for example, I'm using Bash, which means a Linux Bash. So if you are using Bash, run the following code on Bash. So I just copy this part of the code. So it will redirect you how you can configure, because I'm personally using Linux and I'm installing on Linux machine. That's why I need to export the paths on this. So I just copy this, then I can paste in the Linux command or bash. So here, as you can see, here, I just copy here and enter. Then Mojo is configured. So I can then enter Mojo command or bash on the terminal. Then welcome to Mojo. Mojo is started. Okay, this is how you can install on Linux. Once the SDK is installed on your Linux machine or your machine, you can open up the VS Code, Visual Studio Code for editing Mojo program, and you can go to the extensions to install Mojo extensions. That's good. That will help you to format your code and everything. It will help you. Then you can type Mojo and you can look at the Mojo, this part, because there are different modules, but this is the verified modular. So you need to look at the verification symbol, right? Tick mark, and then you can install the Mojo on your VS Code. Once the module is installed on VS Code, you can go to the setting. You need to configure the setting, the extension, the paths of the modular SDK where it is installed. So let me show you on the terminal. So it's just show you where it is installed. Yeah, this is the modular home. You can find this home now, this path. This is the modular home, and you can copy this path only and get back to the modular, and you can paste here. This is the modular home path. You paste here and then enter. Once you finish configuring, you can go to the code editor of Mojo and you can write your first hello world program. And once you have successfully configured your Mojo program development kit or software development environment, you can edit your first Mojo program like hello world. Then you can run your first Mojo program using Mojo file name dot Mojo. Mojo is an extension of Mojo Programming, and you can enter and you can see that here already is printed out on the terminal. I hope you enjoyed this short video tutorials on how to configure Mojo software development kit on your computer. Don't forget to like, share, and subscribe, and see you in the next video. Welcome back to Day 2 of Basic Mojo Programming for Artificial Intelligence tutorial. In this tutorial, I will cover an introduction to Mojo Programming, how to get started with Mojo, the functions, variables, and data types in Mojo Programming. Mojo is a systems programming language designed for performance and efficiency. It is a statically typed programming language, which means that the compiler can check for many errors at compile time rather than waiting for the program to run. It also has a number of features that make it well suited for writing high-performance code, such as zero-cost abstractions and low-level memory management. Mojo is an easy-to-use as Python, but with the performance of C++ and Rust. Mojo allows you to leverage the entire Python ecosystem, so you can continue to use the tools you are familiar with. It is designed to become a superset of Python over time by preserving Python's dynamic features while adding new primitives for systems programming. So to start Mojo programming, you need to install the Mojo SDK on your computer. You can watch the previous video tutorials how to install and configure Mojo on VS Code and computer. So now let's get started. Create a new file, for example, day2.mojo. Mojo is an extension for Mojo program. So now I have just created my first Mojo file, which is day2.mojo. Now let me show you a simple Python code, how to run using Mojo compiler. Hello world. This is a simple Python. If you are familiar with Python, this is a Python code and it can be compiled by the Mojo compiler. And to run this code, you can use Mojo space day2.mojo. Then you can run and see the output. Yeah, that is hello world. This is your first Mojo program, but the code is written in Python because Mojo supports all features of Python, added with the performance of C++ and Rust. But Mojo has fn keywords to define function instead of using def keyword. So let me comment this and let me show you how you can define the Mojo function using fn keyword. Fn main, and you can print out hello world with Mojo. Okay, then you can run the code and you can see the output hello world with Mojo. So this is a keyword in Mojo to define a function. This is a def keyword to define a Python function. Okay, but both actually work in Mojo, but using fn behaves a bit differently. Basically, Mojo supports all of Python syntax and semantics. If you are not familiar with Python syntax, you can find Python basic tutorial playlist in my channel and learn from it. Like Python, Mojo uses line breaks and indentations. For example, here it is a block of code that breaks the lines, and every block of code should be indented in Mojo while using a pen. That is the same with using def keyword in Python. So if you, for example, unidentified this code, it just generate an error because this is a great features of Python that includes in Mojo. And Mojo supports all of the Python's control flows syntaxes such as if conditional statements and loops. However, Mojo is still under development, so there are some things from Python that aren't implemented in Mojo yet. All the missing Python features will arrive in time, I hope, but Mojo already includes many features and compatibilities beyond what's available in Python. So Mojo functions can be declared with either using the def keyword or fn keyword. But the fn declaration enforces a strongly typed and memory safe behaviors, while def provides Python style dynamic behaviors. So if you are using the Python style using def, it is a dynamic style behaviors. But this, if you are using fn, it is a static type behaviors and memory safe management behaviors. So I will show you the difference between the two practically. Both fn and def functions have their value, and it's important that you learn them both. However, for the purpose of this tutorial, I will focus on fn functions only. And the other thing is you can declare variables with either using let or var keyword in Mojo. For example, let me declare a variable x and assign, for example, 10 and going to print out uh, the value of that x. So that is 10. So this is the way how you can define variable x using let keyword in Mojo while using fn function. If you are using def keyword, you don't need to use any keywords to define or declare variables. That is called dynamic style behavior because the variables are dynamically reserved in memory. But here it is static typed uh, behavior. Okay, so you can also declare variables if you wanna just modify the variables value. You can use var keyword var y, for example, and if you wanna just modify the values of y, for example, let's increment this by 1. So you can use var, and then you bring the sum of the two variables. Yeah, it is 13. So both used to define or declare variables in Mojo, but they have some differences. If you are using let, which means you can't change that variable values anytime because that is immutable. if you change, for example, the var to let, you cannot modify that value. For example, let me show you let, and let me print out this. Yeah, it is error. The error is that expression must be mutable for in-place operation destination. Because if you are defining a variable with let, that variable is not mutable. That is immutable. If you want to just change the values of that variable, you can define that variable with var. So now it is modified. So no errors on this type. Yeah. So that's the basic differences between let and var keywords in variable declarations in Mojo. So var variables are mutable, meaning that their value can be changed. Once, for example, if you remove this changed value, and if you run that code again, this is error because the variable y is mutable. It can be changed the values of that variable if it is declared using var. That is the basic difference between let and var. So it depends. If you want to just change the values of that variable anytime, you can use var. But if you don't need to change the values of that variable, you can use let. That is the only difference between let and var. Anyhow, you can define or declare variables using let or var in Mojo when using fn function. For example, if you don't, you are using def keyword, a 3, I mean 2, and b is 3. You can print a plus b, and you can see the output. That is 5. But when you are using def keyword, you don't need to statically declare variables. That's why we call Python is a dynamic typed programming language, but Mojo is a static typed programming language when you are using fn keyword to define a function. Okay, that is the basic difference between def and fn in Mojo programming. So keep in mind. Okay, the other thing is in Mojo you can statically specify the types of the variable. For example, here it is no need to define the type of the variable, but you can statically define the type of the variable. For example, integer. So the values of this variable must be integer. For example, if I put 10.3, this is floating, so it just highlight an error. Okay, because the type of this variable is integer, the values should be integer. That is, if you specify the type of that variable, otherwise it accepts any value, doesn't matter. If you don't specify the type of that variable, it accepts any values. That is the future of Python. But sometimes it is recommended to specify the type of the variable that the user imports it to input the same types of that variable. So Mojo has a variety of built-in data types, including integers, floatings, strings, and booleans. So this is an explicit variable type declaration. If you specify the type of that variable like this, declaring the type is not required for variable declaration in fn keywords, but it is desirable sometimes because sometimes it is recommended that enforce the users to input the same types of value. If you omit it, Mojo imports the type as shown here. So this is the basic Mojo programming. I hope you enjoyed this tutorial. Don't forget to like, share, and subscribe. Write comments below. See you in the next video tutorial. Welcome back to day 3 of Mojo Programming for Artificial Intelligence tutorial. In this tutorial, you will learn fundamentals of functions in Mojo Programming. In this tutorial, I will cover how to define functions, arguments and returns, option arguments and keyword arguments, and also how to define argument mutability and ownership of function arguments. Function is a common terminology in all programming language. It is a block of code that can be reused multiple times. It can take arguments and return values as well. Here is the way how you can define function using append keyword in Mojo program. The append keyword is a keyword that's used to define function in Mojo programming and followed by the name of the function. For example, here I used do_math that can do any mathematical operations. So this is called a user-defined function, and every function has a block of code that can be executed. So inside this function, I have defined the variables x and y and assigned values to those variables. And also another variable that stores the sum of the value of x and y. The last statement prints the result of race variable. So inside this function is called a block of code or body of the function. But Mojo is a compiled programming language like C++, so it requires the entry point of the program execution. So this is called the main function. Every compiled programming language should begin the execution of the program from the main function. And we call other user-defined function inside that main function. So in this case, I just called the name of the function I have defined here inside the main function. When you run this code, it begins the execution of the program from the main function and automatically calls the function do_math and prints out the block of statements inside this do_math function. Let me run this code and see the output of this code. That is 15 because this 10 plus 5 is 15 and it returns the result of or the statement inside the do_math. And the other most important thing in function arguments and returns. Although types aren't required for variables declared in the function body, so they are required for arguments and return values for an append function in Mojo program. So let me comment this and let me define another function which is adding two numbers, for example, add and text arguments like x and specify the type of the function per argument and another argument which is y, and we can also specify the type of the function, for example, integer. So every types of function except void should return values. So this function should return value x plus y because I statically define the type of the function which is integer and also statically define the type of the arguments inside this function. Okay, so this function returns the sum of x and y, and the return value should be integer, and the input of the arguments should be integer. Then I call the function here and store the result to the variable z, and I call this function, and it just highlights errors because add calls expected two arguments, but zero were specified here because I have defined two arguments. So I need to pass two arguments to this function. The first argument is, for example, 2, and the second argument is, for example, 3. If you pass more than 2, it still generates an error because the function has two arguments only, and the number of values we pass to the function and the number of arguments must be equal. Now I can print the value of z, and the function automatically calls here and assign 2 and 3 to the arguments x and y. And this function returns the sum of x and y. Let me run this code and let me see the output of the code. Okay, that is 5 because assigns 2 and 3 to the this function parameter arguments, and it's returns the sum of the arguments. The other thing in the function arguments is optional arguments. So we can assign default values to arguments. For example, let me assign default value to the argument y, and I can remove this. No error here because the second argument in this function has a default value. If I do not specify or pass the values to the second argument, it automatically takes the default value to that argument. And let me see the output of this code. That's 4. So initially, it has a default value of 2, and I didn't pass any values to this argument, and it takes the default value. If I pass, for example, 4 to the second argument, it will take the new value instead of the default value because it is optional. So if you do not pass the values to the default argument, it will take the default value as input. Otherwise, it will take the passed value to that argument. So this is called optional arguments or default argument. The other thing is argument mutability and ownership of arguments. In this case, you can't modify the argument value. So this is called borrowed arguments. So this is called borrowed arguments because you can't modify the argument x and y inside the body of this function. For example, let me modify x, increment by 1. It is error, so expression must be mutable for in-place operator destination. So because borrowed arguments are immutable references by default, so we need to give ownership of the arguments to modify the values to make it mutable. The other thing is, optionally, we can use borrowed keywords to define borrowed arguments. By default, arguments are borrowed arguments, but we can also specify the borrowed keyword, and that is called borrowed arguments. Because FN arguments are immutable references by default, this ensures memory safety, which means no surprises changes to the data, while also avoiding a copy, which could be a performance hit. So this is also called borrowed arguments. You can make it explicit with a borrowed declaration as showed here, like this, and this behaves exactly the same as the previous one without borrowed here. For example, this and either using borrowed keyword or without borrowed keyword, this is called borrowed arguments. You can't modify the values of the arguments inside the block of the function or the body of the function. But if you want to just modify or to make it mutable, you can use in-out arguments. For example, in-out keyword. So when you are using in-out keyword, automatically make an error in the function code because you are required to modify or use the variable var, for example, var a assigned to, and then you can call that variable because this is modifiable, and this means that changes made to the arguments inside the function are visible outside the function as well. So, for example, this function is able to modify the original variable. So you can modify x increment by 1. So the original variable value is 2, but here you can modify uh, inside the block of code or function. So when you run this code, and you can see that this is 7. Initially it was 2, but I have modified this inside the body of the function, and it is 3. 3 plus 4 is 7. So this is called in-out argument. So you can use in-out, for example, even you can use the second argument in-out, and you should define the outside variable, for example, 4 and b. Then you can modify the, for example, y3, and you can run this code. That is 10. Initially, I assigned 2 and 4 for x and y arguments, but here I modified the arguments inside the function, and the result of the values are changing. Okay, this is in-out arguments. So this is for day 3 tutorial, and I just give you an assignment that is called reading assignment about owned arguments and how to transfer ownership of the arguments in Mojo Programming. And I hope you enjoyed in this tutorial. Don't forget to like, share, and subscribe. See you in the next video. Thanks for watching. Welcome back to day 4 of Mojo Programming for AI tutorial. In this tutorial, you will learn the fundamental concepts of structures in Mojo Programming. What are structures? How to build structures in Mojo Programming. Mojo structures are a powerful feature of the Mojo programming language that allows developers to build high-level and safe abstractions on top of complex, low-level operations without any performance loss. This is because Mojo is based on multi-level intermediate representation and low-level virtual machine, which offers a cutting-edge compiler and code generation systems that used in many programming languages. Here, let's construct structures in Mojo. To construct structures in Mojo, we use struct keyword and followed by the object name. Mojo struct is similar to other object-oriented programming language like classes and objects. So we use the struct keyword to build Mojo structures. A struct in Mojo is similar to a Python class. If you are familiar with Python, it is completely similar to the Python class, and everything is similar. They both support methods, fields, operator overloading, decorators for meta programming, and many more. Their basic differences are Python classes are dynamic. They allow for dynamic dispatches and dynamically binding instance properties at runtime because it is interpreting programming language. But Mojo structures are static because Mojo programming language is one of the static type programming language. It is a compiled programming language and everything is static. They are bound at compile time because it is one of the compiled programming language. You cannot add methods at runtime, like interpreting language like Python. Structures allow you to trade flexibility for performance while being safe and easy to use. They have fixed memory layouts because it is static programming language, and once you statically define variables, methods, and objects, so they have fixed memory layouts. You don't need to dynamically reserve memories in computer like Python, which makes them more efficient and easier to optimize. They can be used to directly access data fields, which improves performance and makes code more concise. So here we define fields inside this object. So this is a student object has attributes or fields that defines the student. For example, uh, a student has first name, and we statically define the type of the student, and the student has last name. That is strongly recommended to statically define the type of the data or the fields, and we add, for example, an integer type, which is age. Now, so all fields can be defined inside the object, and every object has methods, fields, or any other decorators. So we need to define the constructors. So every object in object-oriented programming, every object has constructors that can construct or build instance of the object. But this has the features of Python, and Python doesn't support constructors, but it has a default method that is init method, which is called render, that used to construct a constructors. So we define the init method, which is similar to Python, and this init method can pass arguments such as self, which is the keyword or the argument of the constructor. When you are instantiating objects, the object is automatically attached to the self keyword, and you can refer the object through these keywords. Like, so this is a great feature of Python. And also you can define other methods such as the fname, lname, and age as an argument to this constructor. When you are calling the object and creating an instance of that object, automatically pass the arguments to the init method through the self keywords. So the object can be automatically provided the values to this self argument, and you can also define the other arguments to this lname and age, which is int. Now you can, but here self-instructs must be passed as mutable references. If you are new to this, you can watch the previous tutorials about functions, arguments, and mutable and immutable features of arguments in Mojo function. So we should make it mutable to pass this object to other methods, and to pass the values to this argument self, which is the instance of the object. So we need to make it the mutable using in-out keyword. So you can watch previous tutorials about in-out, borrowed, and ownership of the function arguments. Now it is we can access, so because it is mutable right now, and it can be visible inside the method and outside of that method as well. And now I can modify that argument fname, and that I can assign fname and self dot lname, and the other is self dot age. Here is okay. All right. Now everything is fine. The next is define the function that's going to return the data of the field is defined in this object. So we need to define another function or method. And now we can access the self argument, which gets the values of the instance of the object. And because it is mutable, and we can access that everywhere in the class or object. Now I can print the name, which is self dot name, self dot name, and I can also edge, which is self dot edge. So when you are calling this method through the instance of the object's student through self keyword, so it's going to print out the data of the students. Okay, so now we need to call the object outside of the class. It is one of the behaviors of object-oriented programming. So we now, but here in Mojo programming, we need to define the main function, because every program in Mojo begins from the main function, because it is an entry point for program execution. It is similar to C++ or Java. So we need to define that main function, main. And now we can call the object student and create an instance of the student object. That is let std and student constructor. Now I can pass value to the student constructor, because the constructor for student is constructed through the gender method in it. In other programming language, in other programming language of object-oriented concept, we need to use the same name to construct the objects of the student. But here it is a great feature of Python. We need to use gender method like init to construct the constructor of the object. Now I need to pass, because this constructor has 3 arguments except the self argument. Self is the instance of the object, automatically provide the values pass through the object. Okay, now I can pass the first name and last name, and the third argument is age. All right, the next step is just calling the method through the object. Okay, the object is std and std.display. This method has no any arguments except self keyword, which is so. Now we can run this code and using Mojo for.mojo, and we can see the output. Yeah, the name is this one I have provided, and age is this one. So this is the way how you can construct structures in Mojo programming that is completed the concept of object-oriented. So it has static nature, as well as it has the Python's programming to define the structure of the module. So module structures can also be used to build a wide variety of abstractions, such as data structures, such as linked lists, trees, graphs, and also object models, such as GUI widgets, network packets, and database records. And module structures also used to build APIs for interacting with hardware and software components. Module structures are a powerful tool that can help developers write high performance, efficient, and reliable codes. I hope this tutorial was useful. Don't forget to like, share, and subscribe, and see you in the next video. Thanks for watching. And welcome back to day 5 of Mojo Programming for Artificial Intelligence tutorials. In this tutorial, you will learn about control statements in loops in Mojo Programming. In this tutorial, I will cover how to implement, how to use control statements such as if-else statement, if-else statements, and also how to implement loops such as for loops, while loops in Mojo Programming. Mojo Programming supports a variety of control statements and loops, which can be used to alter the flow of execution of a program. If you're already familiar in Python's control statements and loops, so there is no additional syntaxes in Mojo Programming. It's already implemented the Python's control statements and loops in Mojo Programming as well. So if you're already familiar with this statements, so it is easy to use in Mojo Programming as well. So the control statements such as if statements, if else statements, and if else statements, those are the statements that used to execute a block of code only if a given condition is true. And the loops, for example, the for loop is used to execute a block of code repeatedly for a given number of times or until a certain condition is met. The while loop also used to execute a block of code repeatedly while a given condition is true. Otherwise, it terminates the loop. So here is an example how to implement conditional statements. For example, let me implement determine the age of or your age. First, let's define a function and that is called determine age. And this function takes one parameter and that is age. And the outputs would be string type. And the input is integer, and it's going to determine the given age is adult or not adult. If age is greater than or equal to, for example, 18, this is a simple Python's conditional control statement that evaluates the conditions either true or false. And if the age is greater than or equal to 18, so it returns you are adult. Else, it return you are not adult. So this is a simple control statement, if-else statement that determine the ages based on the input of age. Now we call this function inside the main function in Mojo and determine the age. Let result and determine the age, and we pass an argument to the age parameter, which is an integer. We always input integer argument to this parameter because we already statically specified the age type. It always accepts integer. So for example, let me input 34 and print the result. Okay, now let me run this code, day 5.mojo. Yeah, you're adult because age is greater than or equal to 18. And if I change this to, for example, 16, and it returns you are not adult because it is under 18. So this is a simple if-else statement in Mojo programming, but this is also similar with Python's programming because Mojo programming is already implemented all features of Python programming. So if you are familiar with Python's control statements such as if-else statements and if conditional statements, it is easy to use in Mojo programming as well. The other is locus. We can also implement locus that is the same with Python's loop. So, for example, let me comment this and let me find, for example, let's print list of numbers from 1 up to 100 list for every I in the range of, this is a simple Python script. For example, from 2 up to 100. For example, if all even numbers, if you want to print all even numbers, you can start from 1 and you can add sorry 2. You can add 2 every to print all even numbers from 1 up to 100, and you can print I. This is a simple for loop, and it's going to print out all even numbers from 1 up to 100. So this is starting, ending, and this is stepwise. And this is a simple for loop, so whatever you can implement in Mojo without any additional syntaxes in Mojo programming. Okay, now I'm going to implement while loops to determine to find the sum of all numbers from 1 up to 100. Let me define a function, for example, append some odd and any number n, which is integer number, and the output is also integer. Now, let me define a variable sum, which is integer and initially assigned to 0, and an iterator, which is I, and this is also integer and initial value is 1. Then while I is less than or equal to n, then the iterator, the sum is incremented by 1, I, by that number, and the iterator is incremented by 2, because I wanna sum up all odd numbers from 1 up to 100, for example, 1 up to n. So I just use this, and finally it's going to return the sum. Okay, so here in this example, I have implemented a function, Mojo function, arguments, and statically declare arguments, and also define the type of the function, which is integer. So it's always a return integer type. And also I implemented variable declarations, while loop is here, and finally it's going to return the sum of the odd numbers from 1 up to n. Now here I just determine sum, for example, sum odd. Let me find, for example, 1 up to 10. Then let's print the result. Now let me run this code and see the output of this while loop. Okay. But never mutated, consider switching to late. Where? Sum was declared var. Okay. I should result. This is, let me change to late. Okay, that's good, because I need to modify that if I define variables using var keyword. Oh, okay. Right now this is the sum 1 up to 10. If you wanna, for example, find 1 up to 100, and it prints that is 2500. and so on. So this is a simple while loop implementation in Mojo programming, a for loop implementation in Mojo programming. I mean, conditional statements or control statements in Mojo programming, and simple for loops using Mojo programming. So if you are already familiar with Python, it is easy to use conditional and loops in Mojo programming as well. I hope this tutorial was useful. Don't forget to like, share, and subscribe. Write comments below, and see you next time. Thanks for watching. Back to day 6 of Mojo Programming for Artificial Intelligence tutorial. In this tutorial, you will learn how to integrate Python in Mojo Programming. Mojo is a work in progress that is not yet a full superset of Python in 2023. However, it does have a mechanism for importing Python modules as is, which allows you to use existing Python code. This mechanism uses the C Python interpreter to run Python code, and thus it works seamlessly with all Python modules today. For example, here is how you can import and use Numpy in your Mojo programming. Let's get started. First, import the Python module. And define the Mojo function to do some array using Numpy. And you can use exception handling to handle if there is errors. Right. Let's define a Numpy first by using Python dot import underscore module function, and we define the Numpy in this case. Now let's define array, and let's define an array with a shape of 3 by 5 and in the range of 15, and let's reshape that 3 rows by 5 columns. Then we can print the array, ARR, and now we can also print the shape of the array, ARR.shape. So you can perform any NumPy functions or methods inside this Mojo program. So once you import the C Python interpreter in your Mojo program, then you can handle except if, and if there is error, you can print that error. Then we can call that inside the main function to perform this array operations using NumPy, and let's call to array. Okay, now let's run this code. Day 6.mojo, and let's see the output. Yeah, we have created an array of 3 rows by 5 columns, and the shape of the arrays are 3 rows and 5 columns. So this is a simple example of NumPy array in Mojo program by importing the Python interpreter in Mojo. So you can do many things because Python is already integrated with Mojo, and in the future, every Python features can be integrated in Mojo, and you can do many things in Mojo programming as well. I hope this tutorial covered enough of the basics to get you started. It is intentionally brief, so if you want more details about any of the topics touched up or here, you can check out the Mojo Programming Manual online. You can also subscribe to my YouTube channel and receive daily content related to Mojo Programming, Python, machine learning, and artificial intelligence. And don't forget to like, share, and comment below. Thanks for watching today. Welcome back to day 7 of Mojo Programming for Artificial Intelligence tutorial. In this tutorial, you will learn about Python's dictionary in Mojo Programming. In this tutorial, I will delve into how to define dictionary object, how to add new item in the dictionary, how to access dictionary items, how to modify the dictionary item, how to get the dictionary keys and how to get the number of items in the dictionary. Mojo doesn't have a standard dictionary yet, so it is not yet possible to create a Python dictionary from a Mojo dictionary. However, you can still work with Python dictionaries in Mojo. To create a Python dictionary, use the dict method from the Python module. Let's get started. First, import the Python module. And define a function, a Mojo function, main function that's because that's an entry point to Mojo programming. Then we can use the try hash or exception handling that's going to handle if there may be errors in the dictionary. So we can use except if there are any error arise going to handle. Now let's define an empty dictionary objects. To do this, we can define a variable using let keyword that is the dictionary object, and we use the Python module.dict method from that Python module. This is called an empty dictionary. Then we can add a new item in the dictionary. Add new item in the dictionary using dictionary and key name, for example, fruits, and value for that key, for example, apple. We can add more dictionary in this case. For example, starch, which is potato. Okay, now how to access the items in the dictionary? We have added two dictionary items in the dictionary object, and now we can access the item in the dictionary using the dictionary key. So let's print out the item, the dictionary object, and we refer the key. For example, the key is fruits, and going to print out the item in that key. Okay. Now let's run this code and let's see the output of this program. Day 7 goes Mojo. Yeah, apple is printed out. This is the way how you can add dictionary item and how to access dictionary item in the dictionary. The other thing is you can modify the item in the dictionary. For example, to modify the dictionary item, that's, for example, fruits. I want to change the value of the fruits with initially it was apple, now I can modify to banana. Okay, and I can print that item after modified. Dictionary fruits. Okay, let's print out that to see the output. Yeah, initially was apple, and I just modified after this, and the modified item is banana. Okay, so this is the way how you can apply. Actually, if you are familiar with Python's dictionary, it is easy to use all the operations and methods in the Mojo as well. Now you can get the number of items in the dictionary. So to get, let's define any variable n which hold integer value. Okay. And in this case, we're going to use the dictionary object name dot the lender method, which is name. Okay, dot another lender method, which is index. First, it's just get all indexes from dictionary, then counts the number of indexes in that dictionary. Now we can print how many number of items we have in the dictionary, for example, and number of items. Okay, let's print out this and let's see the output. Yeah, we have two number of items in our dictionary. If you add a new dictionary items, for example, let's add new dictionary item. Uh, what's the name? For example, price. Price is, for example, 35. And let's run this. How many number of items I can have? That's 3 because I just added a new item in the dictionary, that is price. Okay. The next is I'm going to use how to iterate over items in the dictionary and going to print out all keys in the dictionary. For example, for every key in the dictionary, and let's print out how many number of all keys for it. This should be outside of this loop. And I can print T. Okay. This. So here I just define the dictionary object with let keyword. So if you define the let variable, so you should change it to var because it is not mutable. So you have to make it mutable to access that dictionary variable or object. So I just modify to var. Now I can do that. So now all the keys are fruits, starch, and price, and 3 items. And I can also access items in each dictionary key by referring dictionary at key. And I can print out this again. Yeah, all the key and values are printed together. So you can access, you can iterate over, you can access any item in the dictionary, you can add new item in the dictionary, you can modify the dictionary item as well. And you can also get how many number of items in the dictionary do you have. So these are a basic dictionary tutorials, how to use dictionary in Mojo function. I hope you enjoyed this video tutorial. Don't forget to like, share, and subscribe. Write comments below. See you in the next tutorial. Thanks for watching. Welcome back to day 8 of Mojo Programming for Artificial Intelligence tutorial. In this tutorial, you will learn how to organize your code into modules and import into another Mojo file. A Mojo module is a file with a .mojo extension that contains Mojo code. Modules can contain functions, variables, and other modules. To organize your code into modules, you can group related functionality into separate files, and you can import into another Mojo files. For example, you might have a module for each of the network communication, database access, user interface rendering, and algorithmic code. Once you have grouped into modules, you can import them into other Mojo files using the import step. A Mojo module is a single Mojo source file that includes code suitable for use by other files that import it. For example, you can create a module named mymodule.mojo, and you can organize your code into this file using, for example, you can define extract, which is to define object, which is my pair, and you can define variables inside this integer variables. And the second is one integer. And you can define the constructor with gender method. And make the self arguments mutable using inout. And other arguments first. And second, which is also an int. Then this could return integer or float. And now let's refer and assign that attribute to this arguments. Here first, and second is okay. All right, let's define a function that's going to perform some operations. For example, dump, and this take a self as an argument because this is inout and it can be modifiable, and I can use, or it can be visible anywhere in the objects. And it's going to print out self dot first and self dot second. All right. Let's assume this is your class or object that's defined using struct as keywords. So this is organized into a separate file called mymodule.mojo, and you can import this into another Mojo files, which is main.mojo. So notice that this code has no main function, so you can't execute mymodule.mojo because in Mojo programming, every program starts executing from the main function. So you need to define a separate function in a separate Mojo file, and you can import this code as a module inside that main function in the main.mojo file. However, you can import this into another file with the main function and use it there. For example, here's how you can import my pair into a file named main.mojo. So you can use from my module, that is the module name. And from that module name, you can import the class or object that is my pair, import my pair, and you can then define the main function and define what object that my pair, and this takes two arguments. For example, let's pass an integer argument to this because we have two arguments in this constructor. Okay, then you can call the method inside the mymodule.mojo using the object name mine.dump, and it's going to print the statements inside this methods or function. Now let's run this code main.mojo module. That's the main function only, because the main function just imported the module, my module dot module, and use the classes inside this file or module. And it's going to print out the statements inside this function, because this function is already called inside the main function of main.module file. Okay, let's do it. Yeah, 2 and 3 is printed out according to the statements here. I just define to print out the numbers we pass to the this constructors an argument, and it's going to print it out that that's 2 and 3. The other thing here that you need to know is you can import the whole module and then access its members through the module name. For example, instead of just importing the class from that module, you can import the whole module. Import my module, and you can then access my module dot my pair. Okay, this is another way, but the previous one is the best way to import a specific class from that module. Because in one module, you may have multiple structures. So if you need to import only one struct from that module, you can use the previous one. You can import specific classes from that module only. If you want to use all modules, all classes from that module, you can import the module as it is. And if you run this code, it prints out the same result. So you can also create an alias for an imported members with it as keyword. For example, you can use as my, like this, my module. So instead of using the module, you can use an alias, short name, that is my, and you can import that. Okay, in this example, it only works when my module.mojo is in the same directory as main.mojo files are located. Currently, you can't import .mojo files as modules if they reside in a separate directories. That is, unless you treat the directory as a Mojo package, as we will discuss in the upcoming video tutorial. I hope this tutorial was helpful. Don't forget to like, share, and subscribe. Write comments below. See you in the next video. Thanks for watching.